Hello again. Thank you for watching this video and studying math with us. This video talks about factoring sums and differences of perfect cubes. Now, you may recall I promised to provide a video covering the topic factoring sums and differences of perfect cubes. This video fulfills that promise and is aligned with Chapter 6.4 in your text. Realize you will be tested on this material, so pay attention to the video. By way of introduction, you might recall that there was a special factoring identity for factoring a binomial, which was the difference of perfect squares. Namely, if you had a squared minus b squared, that could be factored into a plus b times a minus b. And recall also that the sum of perfect squares did not have a similar identity. In fact, the sum of perfect squares is prime, not factorable, unless there is a greatest common factor. So if you run across a squared plus b squared, it's often prime. But inquiring technical minds would want to know, what's the deal with binomials involving perfect cubes? And if you have such an inquiring mind, this video is for you, because that's the subject we deal with here. And here are the two identities. So if you have a cubed minus b cubed, that can be factored into a minus b times the quantity a squared plus ab plus b squared. And similarly, but different, the sum of perfect cubes, a cubed plus b cubed, can be factored into a plus b times a squared, but now it is minus ab plus b squared. Now, one of my students once said, oh, the way I remember what's happening with these signs is I think of the acronym SOAP. And what he was thinking about, it was the word SOAP, standing for same, opposite, always positive. So you see, when you're factoring the differences, it's the same, opposite, always positive. When you're factoring the sum, it would be same, opposite, always positive. So he liked that. I also am going to note in passing that often these expressions cannot be factored, but soon we'll be able to solve them with the quadratic formula, so we will have additional problems that will deal with those. So what I would encourage you to do is to write these identities down, because I'm going to be using them a great deal in what follows. Also, what I would encourage you to do is consider this a work zone where you can pause and replay the video or rewind it to make sure that you do know how to do the problems that are ahead. So, having written down those identities, then we'll start doing a whole handful of examples and go from there. So here it is important that we realize that z cubed is, this is the same thing as z cubed plus 3 cubed. So this can be factored into z plus 3 times, this is going to be z squared, this is going to be minus 3z, and then it's going to be plus 3 squared, or 9. So that's what we would get as the answer to factoring that one. Let's move to another example. Here is a difference of perfect cubes, but in order to get there, one must realize that this is d cubed minus 5 cubed. And then this will factor into d minus 5 times d squared, and now this is going to be plus 5d, and then it is plus 25, because that's 5 squared. So this would be the answer to factoring that one. Let's look at this one. It's a little more complicated. We have to realize that 8 is 2m. 8m cubed is 2m whole cubed plus, and this is going to be 5 n whole cubed. So that means this is going to be a plus b times a squared, and then it's going to be plus, this is going to be 10m n, because it's the product of those two, and then plus, this will be 25n squared. So the factorization here would be this one as the answer. And there, I moved it onto the screen. Okay, let's look at this one. Now, this one is a little bit different because this requires us to realize that 1 cubed is the same thing as 1. So you see, this is going to be c minus 1 times c squared plus c, because it's the product of 1 and c, and 1 squared is 1. And so this is the answer for that one. This is going to be 4y whole thing cubed minus 5g whole thing cubed. So this is going to be 4y minus 5g times, and this is going to be 16y squared, and it's going to be then plus 20yg, and then it's going to be plus 25g squared. So that would be the answer to that problem factored. This is very similar to one we did before. This is going to be y plus z times, and this is going to be y squared. Then this is going to be minus yz, and then it's going to be plus, and that will be z squared. Now, sometimes you can do multiple techniques. For example, the first thing you do in a factoring problem, the last thing you do in a factoring problem is factor out the greatest common factor, and that's the first step we will do here. So we'll factor out a 4, and then we'll have, this is k cubed plus 27. So then this would be 4, and then I will be factoring that, and I'll further realize that that one is 4, and then this is k cubed plus 3 cubed. So I'll continue factoring then, so I will have k plus 3, and this is going to be times, this will be k squared. Now this will be minus 3k, and that is plus 9. And so now that is the complete factoring of that one. Another example is this one, where what we're going to realize that this is the same thing as x squared whole cubed minus y squared whole cubed. So I need to factor this until I can't factor it anymore. So what I'm going to say that is, this is a minus b times a squared, and that's going to be x to the 4th, and then it is going to be, let's see, minus, then it's going to be a plus. This is going to be x squared y squared, and then I will be plus, and this is going to be y squared squared is y to the 4th. But I'm not finished yet because this is a difference of perfect squares. So this can be factored into x minus y times x plus y times x to the 4th plus x squared y squared plus y to the 4th. So finally, we have the completely factored answer to that one. And I think this is the last example that we'll have. But what we have is, this is x to the 6th minus 2x cubed plus 1. That is really x cubed minus 1 whole squared. So if we're factoring this completely, what would happen is I would end up having x minus 1 times x squared plus x plus 1 times x minus 1 times x squared plus x plus 1. And I guess that's the completely factored form of that, because it's really x cubed minus 1 cubed whole thing squared. So I just factored it twice. This would be the final answer to that problem. And that's my last example. I'm going to suggest that you go practice these things, and realize in closing, time is precious. Each day must count. Do the math. It will make you strong, and I will see you in class.